Right, very good. So you have understood now this stress strain curve, very important from examination point of view. Not only in board examination and all, even in engineering when you will be going for. So this is a very important concept of any type of material, because knowing the elastic limit of a particular material and then you are going for loading, so it will be increasing the life of the material. Right? Okay. Now we will be discussing something about different types of strain. So types of strain. So first is called longitudinal strain. Longitudinal strain. So longitudinal strain is what? Is equal to change in length by original length. So when the body is changed in length, like a rod is there, suppose a rod is there and you are pulling it, then it will be changing its length. So in that case it will be called as longitudinal strain. Okay. Second one, compressive strain. Compressive strain, you can say that is also coming under that longitudinal strain area. Shearing strain. Shearing strain. So in that shearing strain, what it is there, suppose you are having a cylinder with you and that cylinder is of length L, its original length is L, right? Okay, and now by fixing this particular body on ground, if you are applying any load, so now new position you can say has reached like this and you have got like this, by applying a load F from here. So it has displaced this particular surface, has displaced by angular displacement theta. And this displacement from this particular body, from this particular point, suppose it is some delta x. Delta x. So you can say that shearing strain is equal to delta x. This is the change by the original length of the body. Right? Okay. And this shearing strain occurs due to tangential force or shear force. Shear stress. Tangential force means what? At tangent, at one particular point only you are applying. You are not applying somewhere in the middle. Full body is not pulled at some particular point at the edge. So tangent means what? In a circle, if a tangent is there which is touching at particular point, one point, right? So this particular force is known as shear force or tangential force, right? So stress will be called as shear stress. The stress in this condition it will be called as shear stress, whereas shearing strain. So this force is tangential force or shear force, right? Okay. So these are the two types of strain. Now another one more time, and that is called volumetric strain. Volumetric strain. Okay, so volumetric strain means what? Suppose you are having a closed cylindrical vessel. Vessel, you know? Idli container. Okay, suppose we are having some idli maker, closed container, cooker. In that inside, we are placing water. The fluid will be placed inside or heated, whatever it is. So what will be there inside that fluid will go and will strike the walls of the vessel in all directions. That is only mechanical properties of fluid. Correct or not? So it will be going and pushing the wall all over in all directions. If that deformation is taking place, so that deformation will be taking place completely. In its volume it will be changing. Correct or not? So mainly this volumetric strain occurs due to hydraulic stress. So this is called hydraulic, where fluid is used. Okay, so it occurs mainly due to hydraulic stress. Correct? Okay, and this volumetric strain will be equal to what? Change in volume by original volume. Change in volume by original volume. Delta V means what? V2 minus V1 by V. Here delta X means what? Whatever it was there earlier. Correct? Now that change is there. Delta L means what? L2 minus L1. X2 minus X1. Like this. So hydraulic volumetric strain is occurring when the full volume of the body is getting changed. Full volume of the body will get changed and the ratio will be giving you volumetric strain. Right? Okay. Whether you have noted down? First one you have noted down. Okay. So now we will be studying about modulus of elasticity. Already we have studied. So this is modulus. We are going to discuss about modulus now. So first one is Young's modulus. Second one is modulus of rigidity. So Young's modulus is also called as modulus of elasticity. Modulus of elasticity, which is also called as Young's modulus. Then modulus of rigidity, and then third one, bulk modulus. Bulk modulus. Noted down everyone? Completely? Okay. Now modulus of elasticity, first one. So what it is, which is denoted by Y. So stress. What is stress? Linear stress. What type of stress? Longitudinal or linear stress you can say. Linear stress by linear strain. Linear stress by linear strain means in a straight line. Longitudinal. Okay. So this is modulus of elasticity. And unit will be what? Unit will be of stress only. For each and every one unit will be stress only. So here unit is Newton per meter square, because strain is having no unit. Now second one, modulus of rigidity. So what it is the ratio which is denoted by G. It is the ratio of shear stress by shear strain. Shear stress by shear strain. Okay, so that is called modulus of rigidity. Modulus of rigidity. Okay, so shear stress by shear strain, its unit is also Newton per meter square, or it is Pascal also, because this is the unit of pressure. This is the unit of So it is also Pascal is also written many places. Okay, 1 Pascal is equal to 1 Newton per meter square. So this is modulus of rigidity. Shear stress you know, shear strain you know. Right, very good. Next one. Modulus, bulk modulus. Bulk modulus. Okay. Bulk modulus is what? It is denoted by K. Denoted by K. And this one is denoted generally not by Y, denoted by E. E. Though Young's modulus Y sometimes it is written, but it is E, modulus of elasticity. So it is denoted by G, it is denoted by K. So it is what? Change in pressure. Okay. So what it is? Pressure. What we said? Hydraulic press, hydraulic stress. So that is hydraulic pressure. Okay. So pressure by change in volume, volumetric strain. So Y minus is there?
Change.
Yes. So change will be there here. So change is negative. Right? Okay. That's why K is equal to minus P by delta V. Minus P by delta V. So this is change in pressure, that pressure applied in the body by volumetric strain. So you can say pressure applied by volumetric strain. Volumetric strain. Okay? Right, very good. So it will be giving you delta V by V. So decrease in volume is taking place, that's why this is negative. Right? So K is equal to minus V by delta V by V. So this is called bulk modulus of elasticity. Bulk modulus of elasticity. When shear stress and shear strain is there, modulus of rigidity. When linear stress and linear strain is there, modulus of elasticity. Very important. Okay. So just please note it down. E and G and K. Okay. Right? Okay. Shear stress by shear strain. So how we are writing shear stress by shear strain? So shear stress was F by A only. F by A only. Shear stress means force by area, load by area. Okay. Shear strain, what we have written, delta X by L only. Right. Okay. And this delta X by L is what? It is angular displacement. It is what? Angular displacement only. Right? So this angular displacement theta. Theta was only delta X by L. Right or not? See, this shear strain is what? What I told. That the body is getting displaced like this. So this angle is only displacement. So angular displacement theta is equal to, this is delta X and this is L. Okay. So what you can say, that this sin theta is equal to delta X by tan theta. Tan theta. Tan theta is equal to delta X by L. So for a small angle, when theta is very small, then tan theta can be written as theta only. So thereby we are getting theta is equal to delta X by L. Means our shear strain. Theta is equal to delta X by L. So here delta X by L is theta only. So you can write and G is equal to F by A is what? Your linear stress. F by A equals what? F is what you are applying this F, that is force, load. So F by A, sigma S, and delta X by L is angular displacement, so theta. So from here we can find shear stress. Shear stress you can find as modulus of rigidity G into theta. G into theta. Correct or not? Okay. Here generally E is equal to, this stress is denoted by sigma, and we will write as sigma L. Sigma L is what? Longitudinal stress or linear stress. Okay. So this is denoted by
B stresses L.
Right. Okay. And linear strain is denoted generally by some gamma, like this. Okay. So if we are writing like this, then sigma linear stress is equal to E into gamma, and gamma is what? Linear strain. Sigma L, and here gamma. Understood? Right. Here, so the pressure P is equal to, you can say, minus A delta V by B. Yes or no? Or you can write P is equal to minus K gamma V. Gamma B, where gamma B is equal to, that is strain, where gamma B is equal to delta V by B. Understood later? So in this way you will be able to calculate modulus of elasticity, modulus of rigidity, bulk modulus of elasticity. Okay? So now we will be solving some questions. Right? We will solve some questions. Okay. We will solve some example questions first. Whether you have noted down? Very good. Some example questions first we will be going for solving it. So let us solve example question, that is example 9.1. What example 9.1 says? A structural steel rod has a radius of 10 mm. Okay, so given what? A steel rod, and its radius is given to us, R is equal to 10 mm. Okay, and a length of 1 meter, its length is given to us as 1 meter. Now 100 kilonewton force load applied is given to us as 100 kilonewton force stretches it along its length. Right? So the rod is there. The rod is of 1 meter length, and you can say 100 kilonewton force is stretching it. That force 100 kilonewton. Very good. Now what we need to find? We need to find stress A. B, we need to find its elongation. Elongation means what? Delta L. Elongation is delta L. It is not asking strain. Okay, right, elongation. And third one, strain on the rod. Strain on the rod. And D, what we need to find? No D we need to find. Okay. Yes. As I told you that each and every material is having its own modulus of elasticity. Here it is a linear rod is there, so modulus of elasticity is there. So modulus of elasticity is given to us for a steel. This is a steel rod, gentlemen. Okay, so modulus of elasticity is given to us, that is E is equal to 2 into 10 to the power 11. 2 into 10 to the power 11 Newton per meter square.
For like this also rigidity also rigidity.
Rigidity, if it will be there, then we need to have some shear stress, shear strength.
No sir, they will give that values.
Value, if modulus of rigidity will be asked to you, then it will be given to you 100%. Modulus of rigidity also will be given to you. Okay? Similarly, bulk modulus also will be given to you. K, value of K. So E, G, K, you will be given value in examination. Now in this case, steel rod is there. So as modulus of elasticity is given to us. By utilizing these things, we need to solve this question. First, the very first thing whenever you are solving any numerical question, see for the dimensions. Those dimensions bring it to standard unit. Very first. Like 10 mm is given to you. So immediately we should make it as 10 into 10 to the power of minus 3 meter, that is 10 to the power minus 2 meter. The very first thing, millimeter has to be changed to meter. Length is already given in meter. Force, kilonewton it is given to you. So 100 into 1000 Newton. So what it is? 10 to the power 5 Newton. Immediately we should convert it. Otherwise our calculations will become wrong. E is already given in Newton per meter square, so no problem. Sometimes it will be given to you millimeter square. Okay? Right. Now the very first thing we need to find is stress. So sigma L is equal to what? Applied force per unit area. Area we are not having, but we are given R. So as it is a circular steel rod, so area will be equal to pi R square. Area will be equal to pi R square. Okay. So pi means what? Some 3.14 will write into R is given to you 10 to the power minus 2 square. So it will become 3.14 into 10 to the power of minus 4 meter square. Yes or no? Okay. Now load is given to you. So load is 10 to the power 5 Newton by 3.14 into 10 to the power of minus 4. Right? Okay. And its unit will be what? Newton per meter square. Yes or no, gentlemen? Very good. So now we need to solve it. We need to solve it now. Okay. 10 to the power 9. Okay. And with this also, if we are changing, then it will become 10 to the power minus 6. Yes or no? It will become 10 to the power minus 6. And 6 plus 5, it will become 11. Correct? So 10 to the power 11 divided by 314. So now this 314, so we can say 1000 to take it into 10 to the power 8 divided by 314. So now we will divide it. So if we are dividing it, so some as a rough figure if I am taking 3 times it will go 942. Okay, so 3 into 10 to the power 8 Newton per meter square. If you want, you can put 1 decimal. Okay, if you want, you can put 1 decimal or 3 into 10 to the power of 8 also you can write. Problem is not there. Right? So in this way you can solve it. So this is stress. Okay, now elongation. So elongation we need to find. Okay, what are the things we are given to us?
L2 minus L1 elongation. L2 minus L1.
No, L2 minus L1. But in this case, what it is there? See, Young's modulus of elasticity is given to us. So it means we are knowing that E is equal to sigma S by strain. Correct or not? Okay. So if we are finding this strain, this is there with us. So strain will be equal to what? Strain will be equal to sigma S by E. From this E will go this side, this strain will come. So strain is equal to sigma S by E. Sigma S already been found. 3 into 10 power of 8 Newton per meter square by E is what? This one 2 into 10 to the power 11 Newton per meter square. So what it is giving you the value? It is giving you 3 by 2. So 1.5 into 8. This will go at the top. So minus 3, 10 to the power minus 3. There is no unit for this strain. No unit. So this both have got cancelled. So 1.5 into 10 power minus 3 is the strain. So that is C, not B, C. Okay, so here you found strain, here you found stress. Now B, now you will find elongation. So that is B, elongation. So elongation means what? So strain is equal to delta L by L. This one already we are having. So elongation delta L will be equal to strain into L. So strain already we have found this one 1.5 into 10 power minus 3 into L is given to us as 1 meter length. So 1 meter. So this is 1.5 into 10 power minus 3 meter. So elongation is 1.5 into 10 power minus 3 meter. Right, gentlemen? Understood? So this 1.5 into 10 power minus 3 meter. Stress we have found, elongation we have found, strain we have found. Okay, so just note it down.